last couple of review problems. We've got number 26 and number 28. There's going to be another video where I do 27 and 29. 26 and 28 are pretty similar, so I thought 27 and 29 might be more valuable. Either way, you'll have all these last 4 problems here, or 4 of the last problems here. Alright, number 26. We have 3 different logs and they all have the same base. And so what we're going to try to do is end up with 1 log on one side and 1 log on the other side, because we know that this 1-to-1 property says that if we have, for example, log base 2 of x is equal to log base 2 of 2, then we can just look at what's inside that log, just look at the argument, and we know x must equal 2, right? Because log 2 of 2 has to be log 2 of 2. All right, so what we're going to try to do is get a situation like that with problem number 6. The product property says that if we are adding 2 logs, we can turn them into 1 log where we multiply the arguments together. That's 2 sets of parentheses, so it looks kind of crazy, but all it's really saying is we've got log base 2 of negative 6x minus 30, and that has to equal log base 2 of 28. And now we have this very situation we were talking about earlier, log base 2, which means what's inside those logs, that argument inside the logs, has to be equal. So we got negative 6x equals 58. We divide by 6, and we'll get 58 over 6 divided by 2, that's 29 over 3. 29 over 3. I will go running over to my calculator real quick and make sure that's correct. So I said that 29 over 3 was x. So if I do math off of math, the log base 2 of 6 plus the log base 2 of negative x minus 5, log base 2 of negative x minus 5. So I plug those in. Whoops. Oops, that's supposed to be negative 29, huh? Supposed to be negative 29 over 3. And you probably noticed that. You probably noticed that earlier, but I didn't. So, negative 29 over 3 is what we will store to x. And let me see if I can get that to come back up. So now we get that the left side of that equation is 4.8. And what's the right? The right side is log base 2 of 28. So log base 2 of 28. And we see that those 2 sides of the equation are equal to each other, and that's exactly what we want to see. So we know that negative 29 over 3 is correct. We don't have to wonder about it or be nervous about it. Then on number 28, it's basically the same thing. We have 2 logs on the left side that are being added together, but because they have the same base, we can just multiply the 2 arguments. And so we get log base 7 of 5x minus 50 equals log base 7 of 48. We could also rewrite this in exponential form if we just got a number for the right side, but let's work on this 1-to-1 property. So log base 7, we know that the arguments inside those logs must be equal to each other. So we get that 5x must equal 98. So x is 98 over 5, which I don't think can be simplified. And I'll go check that, and then this video will be done. So 98 over 5 I'm going to store that to x, and then I'll type in the left side, log base 7 of x minus 10 plus log base 7 of something, 5. You get 1.99, and that should be equal to log base 7 of 48. And it is, so we can stop this video with all kinds of happiness.